One day, engineers opened the dam tubes and released water where it hadn't been for millions of years. The flow rushed straight into the Grand Canyon, into a dry riverbed that nature had carved over millions of years and long since buried. Water poured in at 264,000 gallons per second, lifting sand, rocks, and silt that hadn't moved for decades. The rocks rumbled, the river rose by 16 feet, and no one knew if the canyon could take such pressure. Until that moment, there was nothing here but heat, stone, and dust. But now the largest man-made flood in U.S. history had begun. That was only the first release. Then they did it again, and again. Each time, millions of tons of water poured into the canyon. The sheer volume could fill the Empire State Building in less than 20 minutes. The consequences can't be reversed, but a new release is about to start. But why flood the canyon at all? Who thought that was a good idea? Time to find out. The Grand Flood. An unobtrusive reminder to do that thing under the video. At 6:20 a.m. on March 26, 1996, engineers opened the first of 4 giant pipes on the Glen Canyon Dam. These pipes are called jet tubes. Basically, they're huge metal channels that let water flow straight out of the reservoir. Over the next 9 hours, the remaining 3 were opened, and then the 8 turbines of the hydroelectric plant were switched on. The water flow rose to 335,000 gallons per second, about half again as much as the maximum volume that passes through the turbines alone. To put it simply, every 2 seconds, as much water went through the dam as would fill an Olympic-sized swimming pool. As the flow grew stronger, the river level rose almost 16 feet above normal. In just a week, 238 billion gallons of water rushed through the canyon. Nothing like this had ever been done before. It was the first intentional flood in history. But before talking about the consequences, we need to understand why they even needed to do that. The river I'm talking about is the Colorado. It runs through 7 U.S. states and 2 Mexican ones. But honestly, it hasn't reached the sea in a long time. Literally, that's become a symbol of the water problems across the entire American Southwest. Once, the Colorado was a mighty river that carried its waters from the Rocky Mountains through the Grand Canyon and all the way to the Gulf of California and Mexico. Now what's left of that power is just a thin trickle, a barely alive stream that can't even make it to the ocean. Kind of a failure from the river's point of view. When researchers went to Mexico to see what was left of the lower Colorado, they didn't find a river, only mud, sand, and dust. Where the water used to roar, there's now just a dry riverbed. The waterway that for millions of years stretched from the Rockies to the Gulf last reached its delta on its own almost 30 years ago. The Colorado River has barely reached the sea since the Glen Canyon Dam was completed in 1966. It did sometimes, but only rarely. The Colorado is actually considered one of the most heavily managed rivers on the planet. There are 15 dams on the river itself and hundreds more on its tributaries. It's basically a whole chain of dams, pumping stations, and reservoirs that manage almost every mile of its flow. But the turning point for the Colorado came in 1963, when the Bureau of Reclamation, a federal agency that builds dams and manages water resources in the American West, completed the Glen Canyon Dam. It stands in northern Arizona, just 15 miles upstream from Grand Canyon National Park. The dam blocked about 186 miles of the Colorado's channel and created Lake Powell, the second largest reservoir in the country. Picture a wall 720 feet tall and 1,600 feet wide. Once it went up, the entire 264-mile stretch of the river from the dam to Lake Mead, the largest reservoir in the U.S., changed completely. And then, just 10 years later, scientists noticed the first warning sign. Sandbars and beaches along the Colorado began to disappear. Things only got worse from there. In the Grand Canyon, especially in its upper section, Marble Canyon, everything changed. Before the dam, millions of tons of fine sand and silt used to flow in from the Colorado Basin. But now that sediment never makes it through. It's trapped behind the dam. Because of that, the sandbars and beaches started shrinking, both in size and in number. What used to recover every spring during the floods was now gone for good. River guides who've been rafting here for years have watched these beaches literally vanish before their eyes. And where the water is retreated, vegetation started to grow. Native coyote willow, along with invasive plants like tamarisk, camel thorn, and Bermuda grass, quickly took over the open spaces. Mesquite trees, which once grew right by the water, began to die because the river had retreated too far away from them. In short, since the Glen Canyon Dam was completed, the amount of sand reaching the Grand Canyon has dropped by more than 90%. Before, the Colorado River followed its natural rhythm. Powerful summer floods would reshape its channel every year. Now the flow is controlled by people and by our city's power consumption schedules. The water rises and falls, but gently and evenly, without those mighty floods that shaped the canyon for centuries. As a result, exotic plants keep spreading. The sandbars are disappearing and piles of rock are slowly taking over the main channel. Scientists looked at all this and realized something had to be done. The solution seemed obvious: release more water into the river. In 1996, they decided to run a series of experiments to find out whether it was possible to bring back the lost sandbars. To do that, scientists began conducting what they called controlled water releases. Basically, they deliberately opened the turbines and extra channels so that the water could bypass them and flow straight into the river. These releases even got their own name: experimental flooding. Essentially, they were artificial floods meant to recreate the effect of the river's natural spring high water, the very one that had disappeared after the dam was built. Usually, such releases make up about half the volume of a real flood and last from 3 to 8 days, but even that was enough for 2 or 3 times more water than usual to pass through the dam during the same time period. By the time they decided to carry out the first test release, the river had already changed a lot. Some rapids had turned into blockages, spots where all the large debris carried down from the side canyons piled up. The water could barely make its way through because the river simply didn't have the strength left to clear its own channel. So, what did that first release look like? The experiment showed that sandbars could indeed recover, but only for a short while. In the first few days of the artificial flooding, the sand began to settle and form new beaches. The scientists were thrilled, but a few months later, when the dam returned to its normal operation, most of those deposits were washed downstream. Still, the main discovery of 1996 was that the sand entering the Colorado River from its tributaries stays there only for a short time. Meaning, if artificial flooding is done too late, when the sand is already settled or being carried away, the effect will be weak. Floods need to be timed right after natural high waters when the river receives a fresh supply of sand from its side tributaries. Overall, the 1996 flood lasted longer than expected. At first, everything went great. The water brought in new sediments and fresh sandbars began forming along the riverbed and banks. Then, as I said, most of it was washed away. Still, the effect was noticeable. Some of the sand settled higher than the usual waterline, and that's where small backwaters form. Perfect spots for fish spawning. The 2 largest rapids on the river also widened. Archaeological sites along the banks weren't damaged, and even the plants trying to reclaim the former beaches were fine. In the end, researchers admitted that the ecological benefits of the experiment far outweighed any potential harm. But not all the consequences of damming the Colorado were bad. For example, trout, which had never liked the warm and muddy water of the free-flowing river, suddenly started thriving in the cold, clear water below the dam. They felt so comfortable that their numbers skyrocketed. The steady water level also helped the riverside vegetation. Trees and bushes that used to suffer from constant fluctuations began to grow into a thick green wall. That, in turn, attracted rare birds, and other animals followed. In fact, a real green ribbon of life appeared along the river. Even tourists started enjoying rafting through the canyon more. The changes looked so impressive that no one noticed the troubling signs hiding behind them. It wasn't until 1983 that scientists truly realized regular floods played a much more important role than anyone thought. They shaped the canyon's landscape and sustained life in its channel. That's why it took so long for people to act. In June of that year, something unexpected happened. Because of rapid snowmelt in the mountains, Lake Powell overflowed, and engineers had to urgently release water from the Glen Canyon Dam. The flow reached 726,000 gallons per second, less than during the most powerful natural floods, but still a colossal amount. This was the first time they had to use special spillways, giant drainage tunnels carved right into the rock alongside the dam. At first, the operators just watched the process, but soon they raised the alarm. The water suddenly turned red. It looked almost biblical. But the reason was that the rushing flow had stripped away the concrete and ripped chunks of sandstone from the tunnel walls. At one point, people seriously feared that the tunnels could collapse and damage the dam itself. Fortunately, that didn't happen. The crisis was stopped, and later engineers completely redesigned the spillways to prevent cavitation, a phenomenon where tiny bubbles form in fast-moving water and then collapse with such force that they tear pieces of rock from the tunnel walls. But the most interesting part came afterward, when the water receded downstream. Scientists and local guides who knew the river like the back of their hand were stunned. Many sections that had once been bare, dried-out beaches were now covered with fresh sand. The flood washed away some of the invasive plants that had spread along the banks and partly restored habitats for river animals. Of course, scientists and river management experts decided to see if they could repeat the success of 1996, and they carried out new controlled floods, first in 2004, then in 2008. Timing was perfect. Seasonal storms had brought huge amounts of sand from the tributaries into the Colorado. It was too good a chance to miss. During these artificial floods, the sand concentration in the river rose sharply. The water turned muddy, whirlpools formed in the channel, and new sandbars began to take shape, the very ones that vanished since the dam was built. In 2004, the flow from Glen Canyon Dam reached 254,000 gallons of water per second. That torrent rushed through the canyon for just under a week. This time, engineers managed to avoid the issues they'd had back in 1996, but there still wasn't enough sand to fully restore the sandbars. The next experiment in 2008 was even bigger. About 290,000 gallons of water per second were released from the dam. The flooding lasted around 60 hours, and once again the river came alive, reminding everyone what it had been like before the dams were built. Thanks to these experiments, scientists and engineers developed a new permanent water release protocol. Now, artificial floods aren't scheduled in advance, they happen when enough sand is built up in the river. In other words, the flood comes when nature decides. The main focus is on Marble Canyon, roughly a 60-mile stretch of the Colorado River that starts just below the confluence with the Paria River. The Paria brings in most of the sand, so everything depends on it. Like I said, the key to this whole system is timing. Start a flood too early, there won't be enough sand. Too late, and the water will just wash everything downstream. To catch the perfect moment, scientists have set up remote-controlled cameras that show how long the rebuilt sandbars last and in which months the effect is strongest. The calculation's pretty precise. Specialists compare how much sand comes in from the tributaries and how much the river carries away. The difference between those two numbers pinpoints the right time for a water release. Then the water picks up the sand from the bottom and spreads it along the banks. Everyone's happy. The sandbars come back, and they're damn important. Back in 2006, the National Park Service limited the number of rafting trips because the number of beaches along the river had dropped sharply. Without beaches, there's nowhere for tourists to pitch their tents, let alone stay safe. Things got a bit better later on. Occasional water releases from the Glen Canyon Dam helped bring back some of the sandbars, but the effect didn't last long. The beaches would appear and then disappear again. Interestingly, the idea of such controlled releases was first suggested back in 1991, quietly, almost in whispers. But just a couple of years later, by 1993, those quiet talks had turned into loud demands. River guides were especially vocal. They had to find camp spots on beaches that were getting smaller, even though millions of tons of sand were flowing into the Colorado each year from the two main tributaries below the dam. That sand simply had to be used. Besides, the sandbars play a much bigger role than it might seem. They're not just places for camping. In the eddies below the rapids, they create backwaters, calm spots where native and introduced fish species live. The sandbars hold vegetation and supply fresh sand for dunes that protect archaeological sites from wind and erosion. We'll get back to those sites later, just keep that thought in mind. But every year the situation gets worse. Increasingly more areas are suffering from erosion, that is, the destruction of riverbanks and slopes by water and wind. These places used to be much more stable, but now the ground is literally slipping away, and the heavier the impact, the faster the canyon loses its beaches and dunes. And here's what different types of erosion look like, the very ones threatening archaeological sites along the Colorado River. Speaking of those sites, the Colorado River carries more than just water, it carries memory. It's an artery that sustained the lives of indigenous peoples for centuries. Along with water, the river carries sand. And that sand protects ancient archaeological sites from erosion. Without it, they would soon be exposed, start crumbling, and vanish under the effects of wind and rain. Most of these sites lie right in the riverbed within Grand Canyon National Park. They were built by the ancestors of Native Americans who still live in these lands. These include stone dwellings, granaries for storing crops, old trails and irrigation ditches, and the fields where corn and beans once grew. The heritage also includes seasonal camps, rock carvings and paintings, petroglyphs and pictographs, plus cooking pits and quarries where stone was once mined. Basically, everything here is history, and an ancient one. The oldest sites date back to the Archaic period, around 9,000 years ago. But most finds in the river corridor are linked to the ancestors of the Pueblo people and date from roughly 750 to 1250 AD. In short, there's a lot here to preserve. But let's get back to the dam and the water releases. What's happening there today? When the U.S. Department of the Interior approved a new management plan for the Colorado River, they decided to carry out regular controlled water releases from Glen Canyon Dam to restore sandbars. Not just once, but repeatedly, so that the river could once again move and deposit sand as it used to. And the results came quickly. After every such artificial flood, the sandbars grew larger. The combined data from the first 3 releases made it clear the shrinking of beaches and sandy shores could be reversed as long as the floods were frequent enough. The program officially began in 2012 when the department adopted a document mandating regular high-flow releases. Just 3 months after it was approved, the Paria River carried nearly 700,000 tons of sand into the Colorado, the perfect moment for the first experiment. The following years saw more releases, in 2013 and 2014, but it turned out that between floods, the sandbars still gradually eroded. Then came the drought. The river's water levels dropped, and engineers had to conserve every gallon to keep the reservoir from running dry. At the same time, the climate changed. Seasonal storms that used to bring sand from tributaries became weaker and rarer. Because of that, in 2018, the releases stopped for a full 5 years. It wasn't until April 2023 that the Bureau of Reclamation carried out another large-scale experiment, a 72-hour water release, the first one after a long break. Ideally, such short but powerful floods should happen more often, but in recent years, the river simply hasn't been able to afford it. So they've got to work with what they've got. And besides, things aren't looking great financially either. Controlled water releases from the dam have turned out to be an expensive business. Every time water bypasses the turbines, power companies lose money. The Glen Canyon Dam generates a lot of electricity, supplying several states, and that's where the eternal conflict between nature and profit begins. To save the river, you need to release more water. But the more water you release, the less electricity you get. And that means less money. The U.S. Department of the Interior, which manages the dam, has set the limits. The maximum release is now around 335,000 gallons per second, the combined capacity of all turbines and bypass tunnels. And if the release exceeds the level at which the turbines run at full power, roughly 235,000 gallons per second, it can't last for more than 96 hours. That's necessary, otherwise the loss in power generation would skyrocket. Still, energy companies keep complaining because they're losing millions of dollars. For them, every gallon of water is a resource that can generate electricity. And if the states don't get power from the dam, they have to switch to coal and gas plants. So now the engineers are trying to find a balance. How do you use the dam so that nature doesn't suffer and electricity production remains stable? The best solution, they say, is the so-called high-flow experiments. Short but intense water releases. They're done when enough sand is accumulated upstream, and with one powerful flush, the river gets everything at once. Still, no one can predict how much it's going to cost. The losses depend on how often and how long such floods are carried out. For example, the first flood in 1996 was estimated at about $1.8 million in lost revenue, roughly 1% of the annual hydroelectric income. And if you add the cost of scientific research and monitoring, the total almost doubles. To be honest though, the Colorado River's problem started long before the dam was built. Nobody ever planned for this many people to live here. Drought and growing demand for water are constantly putting pressure on the river. In 2013, the environmental organization American Rivers included it in its annual ranking of the most endangered rivers in the U.S. and put the Colorado at number 1. The main reason experts say is that the river is managed according to an outdated system. Its water is distributed based on rules that are more than 100 years old, and life back then was, well, a bit different. Water seemed endless, but now we know that's not the case. The demand for water has long exceeded what the river can provide. Today, water from the Colorado and its tributaries is pumped for all kinds of purposes: drinking, irrigation, swimming, even flushing toilets. The river supplies around 40 million people across 7 states: Arizona, California, Colorado, New Mexico, Nevada, Utah, and Wyoming. Its waters irrigate 5.5 million acres of farmland and drive the turbines of hydroelectric plants that power much of the American West. Nearly 20 Native American tribes and 11 national parks, including the famous Grand Canyon, depend on the river. So what can we do about that? Environmentalists keep saying the same thing. We urgently need to learn to save and reuse water. That means not just turning off the tap, but launching large-scale water conservation programs in agriculture, public utilities, and industry. In other words, saving water everywhere and getting the most out of every single drop. Municipalities and landowners need to switch to more efficient irrigation methods, cut water losses during transportation, and look for ways to restore underground reserves. And in the driest areas, it's time to seriously consider importing water, reusing treated wastewater, or even desalinating sea or brackish water. But even scientists admit that's easier said than done. Many of these solutions require massive investments and won't work everywhere. Still, if nothing is done at all, the Colorado River simply won't survive. It's been flowing through the Grand Canyon for 6 million years, and now climate change, population growth, and water consumption might put an end to the Colorado River itself. It's a complicated problem that 7 U.S. states and Mexico have been trying to solve for years, so far without much success. Just so you know, the original Colorado River Agreement was drafted and signed back in 1922, more than 100 years ago. At the time, around 500,000 people lived in the region, and no one imagined the Southwest's population would grow that much. Today, over 40 million people live in the river basin, and the old rules simply can't handle that kind of pressure. Neither can the river. And don't forget, the West is now going through the worst drought in the last 1,200 years, which doesn't exactly help. But what if the Colorado dries up completely? I mean, below the dam. What would that mean for the Grand Canyon? As you might guess, nothing good. The Grand Canyon's already drying out. You don't have to be an ecologist to see it. The ground is cracked, the sand is scorching, the vegetation is thinning, even the air feels drier than it used to. Scientists warn the groundwater levels around the canyon are falling, and in the future, there'll be even less of it. But people aren't only worried about that, or even about the environmental impact of losing such a river. Many point out that without the Colorado, there'll be no more rafting on the Colorado. Well, makes sense. Rafting's actually a huge deal here. Around 27,000 people float down the river through the Grand Canyon every year. It's not just tourism or an attraction anymore, it's a whole culture, a way to see the canyon from below, from the water. But what if rafting becomes impossible? There's no guarantee anything will replace it. Sure, maybe people will hike or bike along the dry riverbed, but it'd be a completely different canyon. All the wildlife here would change. The animals that drink from the river would leave. The plants that used to grow along the banks would die. Everything would become different. More thorns and cacti, fewer trees and shade, and the heat, which is already exhausting, would become unbearable. Honestly, you'd have to be a real hiking enthusiast to wander through the canyon in those conditions. And then there are the locals. For them, water is a matter of survival. The town of Tusayan, located near the entrance to the national park, depends entirely on groundwater. The same goes for the park itself, which gets 6 million visitors a year, and nearby communities like Havasupai, Hualapai, Williams, and Jacob Lake. If groundwater levels keep dropping, it could become one of the most devastating problems for the region. In the coming years and decades, there will be less and less water for people, animals, and plants alike. And for now, the only things we can do to stop the disaster are save water, redistribute it, and create new laws. The real question is whether the people are ready to change their habits for the sake of the future. You owe me a like, See you later.